introduction.
Okay, we're going to try to do a little workshop, and Freddie has volunteered his laptop to show installation of RED system at this moment. And you already have it installed, right? But it doesn't work anymore?
I don't have it installed now.
Oh.
So we can start from scratch.
Okay. Do you work with Git?
No.
So you don't have Git installed?
No.
Because you could take a download, but the best way to install it is straight from Git, so you can keep updating it to new versions.
Okay.
So I would prefer to install the Git version, but we'd have to install Git first. Is that alright, or do you want the RED release package?
Maybe we start with the release package, and then if people want to install it from Git, we can do it later.
Okay, that's also okay. But you have to know that because it's in full development, since a few months I try to keep my bindings compatible with the latest RED release.
Mm-hmm.
But releases are also fairly frequent. So you may have to reinstall when there's a new release. When there's a new release, I don't keep the bindings compatible with the previous release. So Git would be the way to follow the development, but you'd have to work with Git, and you may also need to work with the fossil source control system that I use. So it is indeed simpler to start with the RED release package, but it's harder to follow the development.
Yeah.
So we'll start with the release package. So if you can go to the RED website, yeah. If in Git, if you take this download, it downloads the master branch, I think. Mm-hmm. So you have to go to tags. Oh right, tags. So there's immediately a hurdle to take because everything is in GitHub right now. So you have to know that you need to go to tags, and then there are release packages of previous release tags indeed. So the newest one is 024 with the floating point support, but it's not fully debugged floating point support. So the floating points demos that are new won't work in here yet, but all the other bindings and examples should work in this release.
But the Git version, it works in the Git version.
The floating point demos work in the Git development version. Yeah, right.
And you can't update this version with Git.
Well, actually, what we could do, if we want to take the floating point examples, then you could download where you were just then, because normally you would download this release 024, but if you download here, you get the current master branch, so you do get what's in Git right now, except not as a checked out repository, so you can't update it. But other than that, it's the same as the release tag packages, but you have to know if it's stable. And yesterday Nenad merged in the two experimental branches, so we know that at this moment this daily package is stable, so you can download this at this moment. So you can simply unpack that. As you see, the package is quite a bit larger than Nenad said in his presentation about the core code. The documentation is in here, but I think most of the size is the test suite. And it keeps growing and growing, so the download package is much larger than Red actually is. So if you would release it, you'd leave out the test suite and it would be much smaller. So you have a folder with it now, right? So what we can see here is what I just said, the documentation directory, the test suite, Peter Wood's quick test, unit test system. There's a folder for the Red code, which is in development and doesn't do anything yet. But there's a start of the runtime and the lecture and the memory allocator, as Nenad said. So what we really need right now is the Red system directory. So that's where we'll work in. The Red compiler, the Red system compiler, is written in REBOL. And actually it requires REBOL 2. And the easiest way to include it is to install REBOL right in this directory of Red system. It's all a bit Windowsy. It doesn't really follow the Unix conventions of having everything separately installed and having it in binary search paths. That's something to arrange, to smoothen out for the future. But right now we're putting everything in the Red system directory to have it work as easily as possible. Right, the REBOL website, I think you can go straight to downloads, yeah. And you don't really need REBOL view. Last year you needed REBOL view, but Nenad implemented his own C structure library, and since then it also runs on REBOL core. So you can now either choose REBOL view or REBOL core, whatever you want, but Red doesn't use the view features, so the smallest thing to do is indeed to take REBOL core. The Windows version is on top, but it works equally well on Linux and basically on all the REBOL platforms that you see here. All of them should be able to run the Red system compiler if you install the REBOL version for your platform.
Install it here?
Yeah, just copy it into the Red system directory. You don't need any installation. And we're going to work from the command line. So it's easiest to rename it to REBOL or R2 or something short. Okay. So if you open the prompt in this directory, is that where you are already? No. Okay, very well. So we'll do a little test if you can start REBOL from here to see if that is functional. See, you get into a command line. If you had installed REBOL view, you'd have to make sure that it doesn't start the desktop, so you'd have to give an option to start REBOL. So it's actually slightly easier to use REBOL core because you will always be in the shell. And I like to start everything from the prompt. So I like to go out of REBOL here with just simply with Q from quit. And then if you recall this command. And then, because Red system is written in REBOL, it's simply a REBOL script. and it's the rsc.r script that you see there. It's the red system compiler.rebel. So if you give that script to REBOL, and we can test if this works. So you see now that instead of just loading REBOL, it loads the entire compiler script, which is nicely modularized in something like 10 modules here. So it's nice to see how it starts. And I like to start everything from the terminal. So if you quit this again, Q. Oh, okay. In the tests directory there are two very small red system scripts, programs really, because they're going to be compiled. Everything so far has run in the REBOL interpreter, and now we're going to test compiling a red system program. So if you recall that command line, and then as a parameter to the compiler you give the tests directory, and in the tests directory first the empty program. Right. Is there a way to stay in the... Oh.
You need
to
use the REBOL console to get the output.
Oh, that's why you work from the console. I work in Linux, and then you get the output from the red system compiler in the Linux terminal.
You can't with DOS.
So I was wondering why you start the REBOL console, because it's annoying in Linux, but we'll have to do that in Windows here, because otherwise the output from the red compiler disappears. Yeah, right. So then you start the compiler from here. You have to do that with the REBOL do function. And then to start a file name, prefix it with a %. And then the same thing, the red system compiler.
You can use tab also.
And then the tests empty program. Does tab? Tab completion?
No, it works only on file.
Oh.
I think it won't work like that. You need to do /args to pass the argument to the script.
I was wondering why the Windows examples, or the examples in the documentation, are so convoluted. And apparently that's because of how Windows works. So you're not going to be bothered with that if you work on a decent Unix platform. But if we start by doing the same thing we just did from the prompt, do that from the REBOL console, we'll see what the result is. So let's first try this. And then, as Nenad said, we have to pass the arguments in a different way. So can you recall this? Yeah, the arrow up recalls this command, and then Nenad will remember by heart what you have to add.
Just double quotes.
Quotes?
The second argument.
Quotes around the red system program?
Yes, around all the arguments passed to the script, and you have to do /args, the refinement for passing arguments to the script.
Okay.
Slash args, R. Just that.
And then an end quote.
Yes. Make sure the...
Okay.
Try like that. Okay, it works.
Okay, it works. Now you see that it's a very small program, but it does need to compile the standard red system runtime, and it doesn't use it because it's an empty program. But the runtime will be compiled in anyway. And you see that results in an executable of 5.5 kilobytes. So there's a bit of runtime in Red System, and it compiled in 1/10 of a second. even though the compiler is a script that is running in the REBOL interpreter. So this is the bootstrap version of the Red System compiler. Red will be implemented on top of Red System, and then the Red System compiler will be ported from REBOL to Red, and we can expect that the compiler will become much faster then, probably an order of magnitude. So from 1/10 of a second it will probably go to somewhere of a hundredth of a second for compiling an empty program with a bit of runtime. It would be handy to stay in this REBOL console where we can recall this command line. So it would be handy if you open another prompt in the same directory to see what the result of this compilation is. Well, I thought we would still be hanging in the REBOL prompt here, but you're still here. So if you see the builds directory, if you go up to the listing, you could see the. Oh no, you have to make a new listing, a new dir. Because there wasn't a builds directory yet, but because this was the first compilation, the builds directory has been created, and there should be the empty executable there, right? So this was just compiled, and if you start that, you see that it's really empty because it didn't do anything. And if you could maybe go to the filer now, very good. We can see what the program is that generated this. It's probably easiest from the filer, right? If you open a filer in the same directory, Windows Explorer. That's in the tests directory where we got the program from. So if you look at the empty Red System program,
you can open it in Notepad, for example.
By right-clicking probably. Yeah, Notepad. Oh, Notepad++. Okay, that's a good open source stuff already. Isn't this the GTK source view widget that Notepad++ is written in? I think so. And that's actually one of the candidates for a Red editor, I think. You want to use the Scintilla widget, and because I'm doing the GTK plus bindings, I'm looking at the GTK source view widget that gedit is based on, and several GTK IDEs. And I think this Notepad++ for Windows is also based on the GTK source view widget, if I remember correctly. So you see that this is really the empty Red program. It only has a header with meta information, and that's a nice feature taken from REBOL. In other programming language you see people making all kinds of weird prefixes to source code files where you define parameters for VI and Emacs editors in weird ways and stuff like that, and the information about the author and the copyrights is usually in comments. But in REBOL this is pretty much standardized by a program header, which is in REBOL format. And Red System has the same thing, only it's called a Red System header instead of a REBOL header. And you can enter any meta information you want, but there is a convention to use certain field names that you see here, and then you can programmatically manipulate scripts, because you know that basically in principle there will always be this header there, that will be in the standard REBOL format. So you can read the meta information with REBOL, and in the future with RED. So that kind of stuff is standardized. And the really smallest program is if you take out all this meta information and you would only have an empty RED system header. So this program is already 5 lines too long for the empty program, but it's still a nice example. So, continuing from that, there's one other test program in the tests folder, and that's the Hello World example. So if you can take a look at that. It's not really the smallest Hello World, but it shows a number of basic features of the RED system language. And it's actually quite advanced because it starts with binding the Windows kernel to get at print functions. It uses it to set color attributes. So here we already have a compile time switch. As a low-level C-like language, RED system has a preprocessor to be able to compile code for different platforms and different use cases without bothering the executable with the code for the other platforms. As in C, if preprocessor directives start with a hash, so you see here an either conditional where you test if you're compiling on Windows, and then you import a function straight from the Windows kernel, and that's a binding in RED system format. You import one function, the set console text attribute function, to be able to get a text coloring in prompt output. And then you see the set pen color function that's defined. That's a RED system function, and it is a wrapper around the set console text attribute function from the Windows kernel that was just imported, and it's a wrapper to make it a little more RED system-like, which is actually a bit more REBOL-like. Well, looking further through the source code, you see that the alternative for that, which is the alternative for the Windows function, apparently assumes that all other platforms uses a standard POSIX terminal with a standard terminal code for setting colors and different numeric definitions for the color values. And then the rest of the code is platform independent. And it shows some print functions and an until loop here to draw a few different text outputs. And it shows a few functions defined in RED system. And if you know REBOL, you will notice that this looks really very much like REBOL. And it really doesn't look like C, although it's it's really a language that's designed at the C level. So if you start programming in this, you get a very strange feeling that you're programming in REBOL, while you know that you're programming at a very low C level, because you can do things like import these Windows kernel functions. And you can import them straight like you would import a C header file, but it really looks like REBOL. It's a really weird feeling. So you feel like you're programming very high level, but at the same time you have access to the lowest level functions from the platform you're programming on. So once you get used to that, it's really very, very powerful. So having seen this code, let's compile it. We still have the REBOL console open. So if you recall the previous version and change the program code to the hello program, right, now let's compile this. And it takes slightly longer to compile because this is a real program. So you see that as a quick estimate, 2/3 of the compilation time were occupied by the runtime, it seems, and 1/3 is now occupied by compiling this hello program. And the hello program was something like 50 lines, more or less, give or take. So you can see that the runtime is larger than that, but it's really quite small. So the result of that is 6 kilobytes. So that's another rough estimate. You can see that the program takes only half a kilobyte. So 5.5 kilobytes is taken by the compiled runtime. So the runtime is really a bit bigger than the compile time would let you think. So the runtime is not negligible, but it's really very small. If you would take a very optimized C program, it may be a few kilobytes less right now, but the output of a red system executable is really not much larger than a very optimized C program with the same functionality. And if you really wanted to make it smaller, you could strip out the part of the runtime that you don't need. But 6 kilobytes for a small program is really very, very, very small. It was even small, I think, in the early 1970s when C was implemented to write Unix in, and the goal was to have efficient executables on the systems that were current in universities 40 years ago, and everyone has those systems in their mobile phones right now, and they're much bigger and more powerful than the mainframes 40 years ago. So 6 kilobytes for a small executable is really an excellent efficiency these days. So let's try to start the thing. So that's what it does. It programs some output in a loop, and it uses the Windows kernel binding to add some red color to it. Well, that's basically the first few steps to get it to work, and the next steps are to get the bindings that exist to work. So if you call up the web browser, and you go to the red language website instead of GitHub, the red web presence is really split among its website and GitHub right now. So if we go to the red site as a launch pad, it's with oh yeah. Then the bindings are listed on the contributions page. So that's what's available right now. It's not entirely complete because there are two bindings to map browsers for OpenStreetMap and other map servers that are not listed here. And the GTK binding has been split into a GTK binding and a glib binding that's not listed here yet. But functionality-wise, these are the bindings that are now available. So in the next step, we'll install these and try to compile the example programs that are in there. But maybe we want to take a small break first. Is that okay with the audience?
It's